All right, so this is the 4A review, which is identifying characteristics of quadratic functions. So let's get started. So this first one's already graphed for us. So domain, we're looking at how far left to how far right does the graph go. It goes to the left forever. Left forever, think about that on the x-axis because domain is the x. That's going to go to negative infinity. And the right side, well, we should continue. We should follow the whole graph and make sure it's continuous, meaning it never has any breaks in it. It is continuous from left to right. And for the right, it keeps going right forever, and right forever on the graph on the x-axis is going to positive infinity. So the domain is negative infinity to positive infinity. The range, looking at the range, we're looking at the lowest points to the highest points, the lowest y values to the highest y values. So both the left and the right side go down forever, and we're thinking y values, which go down. Down is going down to negative infinity. And then how high will this graph go? So we follow the graph. What's the highest point? The maximum in this case is the highest point. There's no other point along the graph that is higher. And what's the y value of that point? The y value is 4. There's an actual coordinate there. We can put 3, 4, but 4 is what I'm looking at, the y value. And there's an actual point there. It's a closed point. Remember that a line is an infinite amount of points put together, closed points, and a closed point means it's a bracket. Increase and decrease in intervals, looking at labeling the graph from left to right. Started from left to right, you're going uphill, so that's increasing. And then your turns and going downhill, so that's decreasing. Looking at the domain of each part, the first part, the domain is coming from the left from negative infinity to the y value, x value of 3. And you can put a bracket if you like, or a parenthesis, does not matter to me. And it's decreasing from 3 to the right forever to infinity. And again, you could have a bracket here or a parenthesis. I tend to do parentheses, but you can also do a bracket. Real solutions, this was something new that we just learned. But a real solution is an x-intercept. So x equals 1. And x equals 5. The y-intercept wears across the y-axis. And let me erase this so I can actually see what's going on. It looks like it crosses at y equals negative 5. Axis to symmetry, this is where the graph, I can split the graph down the middle. And the left and right side is exactly the same. They're mirror images of each other. And that's the x value of 3. And minimum, maximum. Is this a minimum or maximum? That's a maximum point. It's the highest point of the graph. So maximum. End behavior, looking at the two ends of the graphs, left and right. Left end is going to the left forever, and it's going down. How far left will it go? Well, it'll go left to negative infinity. How far down will it go? It'll keep going down to negative infinity also. So the x value is going to negative infinity. The y value is going up and down to negative infinity. So put that down on one of the lines. The other side, the other end of the graph goes to the right forever and down. Right, thinking about the right on the x-axis is going to positive infinity. How far down is it going to go? It's going to go down to negative infinity. So its x value is going to positive infinity, the y value is going to negative infinity. For the graph above, circle all that applies. So a value. So we need to know a value if its absolute value is greater than. So we have it's upside down. That tells us the a value is less than 0. The absolute value, less than 0, not less than 1. Sorry, my bad. Less than 0. This means it's a negative number. Negative number means it's upside down. So we know a is less than 0. And absolute value is, and let's see here. To figure out the other points, look at your 3 main coordinates. And if they are 1 down and 1 over, 1 down and 1 over, left and right, there's no different dilation or scale factor. So it would not be, if it was narrower than that, it would be like a point, it'd be something like here. So it'd be 2 down and 1 over, and then it'd be 2 down and 1 over this way too. So it would have been more like a graph like this if the a is greater than, absolute value of a is greater than 1. If it was less than 1, absolute value would be a wider graph. So, all right, let's look at second problem. Second problem, domain is negative infinity to infinity. It's left to right, it goes forever. The range, the lowest y value is -4. And it's going to go up to positive infinity. Increasing intervals to the right here, it's going to start at the x value of -2. And it's going to go up to positive, or right to positive infinity, not up, right to positive infinity. Decreasing from left to right, it's going to decrease from negative infinity from the left to -2. Again, if you want to put brackets around these, you certainly can, or parentheses. Real solutions looks like at -6 and 2. And you could put it like this too if you want, -6 and negative, or +2, +2. Y-intercept, where is across the y-axis, looks like a -3. Or you could put y equals -3, or you could put the actual coordinate. Axis of symmetry, look at your x value of the vertex, and that's x equals -2. Is it a minimum or maximum? Well, this is a minimum point. The vertex is the minimum point. End behavior, left side is going to negative infinity. It's going left to negative infinity, and it's going up to positive infinity. The right side is going right to positive infinity, and it's going up to positive infinity. And let's look at the a value here quick. So first, the a is, it's right side up, so we know that a is greater than 1, or greater than 0, because it's right side up. And let's look at the coordinates. We have coordinates that are really wide. So this is much wider. If it was a normal graph with key coordinates, no dilations, it would be 1 to the right, 1 up, 1 to the left, 1 up. That would be, this is more of like the parent function without a dilation. This is a is going to equal 0. So if it's less than 0, or if a is less than, the absolute value of a is less than 1, this is a fraction, you get a wide graph, wider graph. And you look, this is a much wider graph. So that's also got to be a. So a is greater than 0, and a is, the absolute value of a is less than 1. All right. Back here, so looks like we have domain, how far left to how far right is negative infinity to infinity. Range, look at the y value from -3 up to positive infinity, because these go up forever. It doesn't matter which side you look at, they both go up, so it just takes one of them. Increase interval from -4 to positive infinity. And you can put parentheses around -4 if you want to bracket. And decreasing from negative infinity to -4. Again, you can put bracket around that. Axis of symmetry, x equals -4. Is it a minimum or maximum? The vertex, that's a minimum. End behavior, looking at the left side of the graph, the x is going to negative infinity. Where's the y going? Well, it's going up to positive infinity. On the right side of the graph, the x is going to positive infinity, it's going to the right, and it's going up also to positive infinity. Looking at the graph, we can't really tell. We just know that the a value is greater than 0 because it is a U-shaped graph. It's not upside down. Can't really tell anything else because we don't know any of the scales, so we can't really tell if there's a scale factor at all. With number 4, domain, it's going to the left forever, going to the right forever, and never stops, so negative infinity to infinity. Range is going from negative infinity, comes from the down below to negative numbers, all the way up to -2. There's an actual point there, so close there with a bracket. Increase interval from negative infinity to 2. And decreasing from 2 to infinity, always the x values. And again, you could have put brackets around these if you'd like. Axis of symmetry is x equals the x value of the vertex, or you can just think it's a vertical line. Vertical line means x equals, and be the x value of the vertex. Is that a minimum or maximum? That's a max point. End behavior, the left side goes to negative infinity. So negative infinity, and it's going down to negative infinity. The right side is going to positive infinity, going right forever. The right arrow is going into the right direction, and it's going also down to negative infinity. It's upside down, so we know that a value is less than 0. It's a negative number, but we, again, don't know on scale factor. It looks like it doesn't probably have a scale factor, but I can't really tell. All right, next one, graphing. So let's graph them. So we got to find the vertex first. X equals the opposite of b over 2a. We have a is -4, b is -8, c is +4. So we have opposite of b is +8 over 2 times -4. Well, that's going to be 8 divided by -8, which is -1. So the x value is -1. Let's substitute that into, you can have y equals, you don't have to have f of x. So let's substitute it in. The left side, I'm not really going to worry about that. This is notation. You could put like f is f of -1, saying you're substituting in -1 for all the x values in the graph. That's really what you're saying there. Oh wait, that's supposed to be a 1. -1, my bad. I know you're yelling at me right now. And simplifying this, so when x equals -1, what does the y value equal? -1 squared is 1. -8 times -1 is a +8 plus 4. So the x value, what is the y value? That's what this is saying here. What's the y value when the x equals -1? It's an actual sentence. It's -4 plus 8 plus 4. So that's going to equal 8. So our vertex is at -1 from here and 8. So vertex is -1, 8. -1, 8. So now we're going to come up with a table. To come up with the actual coordinates for the table, all the other coordinates, what I would do is you look at the a value and look at the denominator. Well, there is no denominator, so we're just going to put it as 1. So we're going to, the other x values that we're going to have 2 x values left on the number line from -1, so that's -2, -3. And we're going to do 2 x values to the right of -1 on a number line, so that's 0 and 1. Again, we went by ones because of the denominator being 1. It's just going to make things the easiest. Now we have to substitute in -2 for the into the equation. So f of -2 equals -4 times -2 squared minus 8 times -2 plus 4. And that's 4, -8. I'm doing -16 plus 16 plus 4. That looks like it's going to be 4. So -2, 4. And we know that they are symmetrical about the x-axis, so we got to think there's a vertical line here, and with left side and right side have to be the same, so also at 0, it has to be 4. Now, if you don't get that, just substitute 0 in, you'll see it'll equal 4. There's nothing wrong with that. And eventually you'll see it. That's nothing wrong. So we got to substitute in 1 or -3. It doesn't matter. Well, 1 sounds a lot easier. 1 squared minus 8 times 1 plus 4. -4 minus 8 plus 4. That looks like it's going to be -8. So 1, -8. So -3 also has to be -8. So 1, -8. And these points are lining up, so that's great. And no, not that one. -3, -8. So this graph is super narrow. And the reason why it's that narrow is because of the -4. Makes it a super narrow graph. X is the symmetry. That's x equals -1. It's the x value of the vertex. And last problem, looking at 6. So we have the vertex is x equals the opposite of b over 2a. So we need to know a, b, and we don't need to know c yet, but we will. So it doesn't hurt to write it down. So opposite of b is -4, so opposite of b is +4. times 2 times, oh my goodness, this is going to be terrible. 2 times 1/3 is 2/3. So we multiply by the reciprocal is divided by, so you multiply by the reciprocal, so 3/2. Otherwise, you could just do this in your calculator. So 4 times 3 is 12, divided by 2 is 6. So, all right, it worked out. Nice. So the x value is 6. What's the y value going to be? 1/3 times 6 squared minus 4 times 6 plus 3. So 6 squared is 36 minus 24 plus 3. 1/3 of 36. Cut it into thirds. That's 12 minus 24 plus 3. So that would be, wait, that's 24. So that's negative 12 plus 3 is negative 9. So vertex is at 6, negative 9. So 6, negative 9. Whoa, way down there. All right, looking at our x values. Well, let's look at our a value. The denominator of the a is 3. So that's what we should go by on to find our other 4 points. So we should look at the x value of the vertex, and we should go by 3's. So 3 to the right is 9 and 12. 3 to the left of 6 is 3 and 0. So subtracting 3. Now we need to substitute in. So we have substitute in, let's do 9 first. 9 squared, it looks like it's going to be a gigantic number. Let's hope not. So substituting in when x equals 9, what does the y value equal? So 9 squared is 81, minus 36 plus 3. 81, 1/3 of 81 is 27, minus 36 plus 3. So that's negative 9 plus 3 is 6. So when the x value is 9, the y value is 6. So 9, 6. All right. So that means when you're 3 to the right of the x, or the vertex, the same as 3 to the left, which is at 3. So 3 is also at 6. 3, 6. All right, we need to do one more point. Let's do when x equals 0. I like 1, 0. You could do 12 if you want. They're going to be the exact same because of symmetrical about the x-axis. So that's 0 minus 0, 0 plus 3. That's 3. So 0, 3, and 12, 3. 0. That's not right. Something's not right here. 0, 3, and 12, 3. Looks like my vertex is wrong. What did I do with the vertex? Looking back. Opposite B. 2A. I am not seeing what I did wrong right now. 1/3, 36, 12. Negative 4 times 6, negative 24. So it's negative 12 plus 3 is negative 9. I'm going to have to get back with you then in class on this one, what this is. So I will work on number 6